Yeah. Right. Let's go ahead and get started. All right. We have a kind of busy day today. First of all, okay. So what I'll do is I will go over the last homework assignment, the one that was due like sometime last week, just to make sure that everybody understands the solution to that one. And then we'll talk a little bit about the pre and post condition homework assignment that's due on Thursday. And then we'll move on to the practice exam for exam 1. Okay. So we have a pretty full day today. Oh, I see where the confusion is. There are 2 pre and post conditions. One doesn't work because one is not.
That one doesn't work.
Yeah, this one is actually
right.
you cannot actually work on it because the due date is about half a year ago, 8 months ago. So I have to hide this one because we are not going to work on this one. Okay, I apologize for that. I did not know that the old assignment is still showing. So I'll go ahead and get rid of it so you can not see it. There we go. All right. So what I will do is to get started with the conditional homework assignment, conditional statement homework assignment, and make sure that we understand why the solution is the solution. Most people got it, without any problem, but I do want to kind of get this out of the way so that we can I can make sure that people understand the solution of that one. I'm making a folder for today so I can save it into today's folder. All right. All right. So are we ready to go? Okay. Are we ready? Okay. Okay. So this was the homework assignment that was due already. I graded this one also. Most people got the maximum number of points. Only a few people got 1 or 2 points. And then some people did not really quite get the concept of a multi-branch conditional statement. And that's why I want to kind of go over this a little bit in today's class, because it's also related to, guess what, the first exam. So we'll go ahead and trace this. There are 3 traces. One person turned in the same file as it is right now. So I cannot give that person any points because it's the same file as it is. I'm not quite sure whether that person forgot to save the file before turning it in, or I do not know what happened. All right, so this is the first test case. With every single test case, you have to start from line 1. In this case, line 1 checks the condition. X is less than 0. X is -5. So is x less than 0 true or false? It's true. So where do we go next?
2.
We go to line 2, and then we change z to 1, and we are done. Okay. Now the most important part is we do need to indicate that variable z got changed on line 2 and not on line 1. Okay. I think a few people, maybe 1, 2, or 3 people, indicated that variable z got changed on line 1, and that is not correct. Okay? So it is changed on line 2. Soft drink. Soda. Cap the soda, please. Yep, thank you. All right, so let's move on to the second test case. The second test case has x initialized to 10. We start at line 1 again. X is less than 0 is false. Where did we go?
Line 3.
So go to line 3, very good. And line 3 checks x is less than 2. It is false. Then where did we go? 5. X is greater than 100 is false also. We move on to line 7. And x is greater than or equal to 0 is true. And so we execute line 8 here, and z gets updated to 4 here, and we are done, because as soon as we take one branch, we get out of the entire conditional statement. Are there any questions about this one?
On this one, what situation will you go when you go to line 10?
Line 10 can be a dead branch. In this case, I believe it is a dead branch. It has to be a dead branch, it's kind of obvious, because this will catch all the cases where x is less than 0, and this will catch all the other cases where x is greater than or equal to 0. So between these two, not even counting the other ones, just between these two branches, it will catch all the cases. That's a good question. So line 10 is a dead branch. Let's look at the last one. It's basically the same thing as last time. On line 1, we have x less than 0 being false. We go to line 3, and we have x is less than 2 is false. Go to line 5, x is greater than 100 is false. We go to line 7, x is greater than or equal to 0 is true. So line 8 will execute, and z gets a value of 4, and we go to post. Are there any questions about this particular assignment? Questions? So that's out of the way. Are there any questions about the new homework? The one that's due on Thursday, the pre and post condition. Yep.
Yeah, first my question was, is it the first line of it? It shows the x is less than, if x is less than what was it, 20? Yeah, x is greater than 20. But in the pre-1, it doesn't mention anything about whether x is greater than 20.
That's correct. But it doesn't need to. Okay, the question was the code, or line 1 of the pseudocode, needs to determine whether x is greater than 20, whether it's true or not. But yet, when I use precondition, the pre-1 does not say anything about the actual value of x, or whether it's even greater than 20 or not. And that's the whole point of using pre and post condition, is it's not a trace. Okay? What we are trying to figure out is, what if we are about to execute line 2? In other words, what can I say about the precondition of line 2? Well, in order for me to execute line 2, live support is out. I can hear the lack of the humming of the air conditioning system, so this can get uncomfortable. So we don't need to know. We don't need to know whether x is actually greater than 20, because if I am about to execute line 2, we know that at that particular point it has to be greater than 20.
Right.
So for the same reason, it's back. On line 4, right before line 4, in order for us to get to the alternative branch, we know that x has to be less than or equal to 20, because otherwise we would not be going to branch to line 4.
I'm sorry, I'm still lost.
We're trying to figure out,
So are we then basically tracing both paths, assuming that in one instance x is greater than 20, and then in the other instance x is not greater than 20?
Okay. We are trying to figure out, the pre and post conditions of the statements. Okay. Any questions? No. Okay. We're trying to figure out the pre and post conditions of the lines. In other words, we're trying to figure out, okay, if we are about to execute this line, what do we know for sure?
Right.
Right after we execute this line, what do we know for sure? That's what we're trying to figure out.
Right. But how can we do that if we don't know if x is greater than 20 or not? How do we know if we go to 3.
Well, we think one thing we do know is precondition is given like this. Okay, so that means if I am about to execute line 2, this still has to be true because I haven't had a chance to modify anything yet at that point. Okay,
All right.
but on top of this, on top of pre1, we also know that in order to end up in the then branch of a conditional statement, we know that the condition of the conditional statement also has to be true.
Okay.
So that's why we can say something in addition to pre1 as pre2. We know that pre1 has to be true, but on top of that, something else also has to be true
Right.
if we are about to execute line 2.
Okay.
Yep.
For the step-by-step, do we need to write the distributed theorems, identities?
No, you can just use what I did in class. So the derivation from line to line, you can just use whatever you want. Yeah, you can just go through that. The only part that I really need explanation is whether you're using the the forget rule or the substitution rule, and why you think you can use it. In this case, I think they're both using the substitution rule. So you have to tell me why and the inverse function exists, and this is the inverse function and all that stuff. Yep.
All right, I have two questions. One is that x times 1?
That's x times 1, yes.
Okay. And then my other question is, does that have to be on the LibreOffice Writer, or could it be on Microsoft Word?
You have to use Microsoft, LibreOffice Writer.
Okay.
Yep. Any other questions? Yep.
Does OpenOffice also work?
Yeah, OpenOffice is fine. OpenOffice or LibreOffice. The AC is on, but I think it's the heater that's on, not the air conditioner. Because I feel warmer than before. I feel warm air going this way. Someone is playing at the maintenance part. Let's see what's the threshold before people actually call. Right? All right. Are there any other questions about the pre and post homework assignment? No questions? Okay. Do you guys have any questions? Seems like this. Do you guys have any questions back there?
No? Good.
Okay, they're good? Okay. All right. So let's go ahead and move on and talk about your first exam. I'm using the exam of the previous year as your practice exam because I think that's the most realistic way to do it. So we'll go ahead and take a look at this file. You guys can download it too. It's just a compressed file. And we'll go and take a look at the first one. All right, so this is one of the questions that I asked in spring 2012. Basically, I give you the pseudocode and you have to trace it. Do you think we can do this? It's a double loop. There's one loop inside another loop. Okay, let's go ahead and do it. I'm just going to go through this and Okay, what do we do first with a trace? The precondition. In this case, since I did not tell you anything ahead of time, you can assume x has an unknown value. On line 1, we're going to change the value of x to 62. And then on line 2, we evaluate the condition. X is greater than 1 is true. Then what do we do? Oh. If the condition is true, where do we go? The line inside. Yep. On line 3, we have to ask another question. X is greater than 3 is true. Then where do we go? Line 4. Line 4, what does line 4 do? It decrements or decreases the value of x by 20. So 62 becomes 42. And then where do we go? Because we have, this is supposed to be end while. Because otherwise it wouldn't make sense, right? Okay, where do we go now? go back to line 3. Line 3 because if you look at the indentation of this and while, it matches the indentation of line 3. So we have to go back to line 3 to ask the same question. X is greater than 3 is, it's still true. Go back to line 4, it becomes 22 this time. Go back to line 3, x is greater than 3 is true one more time. We go to line 4, 22 minus 20 is 2. We go back to line 3, x is greater than 3 is finally false. Then where do we go?
Line 2.
There's one statement tucked away right after the inner loop.
Line 6.
It's line 6, very good. So line 6 has to execute because that's the statement right after the loop from line 3 to line 5. So line 6 is going to decrease the value of x one more time. So it goes from 2 to 1. And then we go where? We go back to line 2 because this is the outside loop. So we have to go back to line 2. Line 2 asks, x is greater than 1, is it true or is it false? It is finally false. Then we are getting out of the outer loop and we get the post. Yep.
Wait, what happened when you put post? Why did you go?
Sorry?
When you put post earlier, were we done with the thing?
When we say post, that means we're done with the trace. The algorithm has exited.
Yeah, why did you keep on going?
Why did I keep on going?
Why did you keep on going? Down. Because it was wrong if you put post back then?
Right, because the condition is true, I have to go inside the loop. This is a while loop. When the condition is true, you get into the loop and not out of the loop. So I put a post there by accident, by mistake. Any questions about this trace? It's not cooling, is it? Each person is like a 200-watt heater. So we have a lot of heating capacity in this room, and it's not cooling down either. So what I'll do is I'm going to save this file into today's folder. So this way you can always go back and take a look. Someone just has to remind me to upload the file, upload the folder from today. Okay, let's move on to the second question. Second question is a pre and post condition question. Your favorite. All right, so here's the question. We confirm about the post condition in this case. And there are two things we need to do. The first thing we have to do is to figure out what is pre-3. And then using that particular pre-3, we want to use pre and post derivation to get back to post 6 and make sure that our pre-3 is in fact correct. Okay? Does everybody understand the question itself? We start with post 6. We want to figure out what is pre-3. But once we figure out what is pre-3, we want to go forward again to derive post 6 again and make sure that post 6 is the same as this post 6. Are we doing okay so far? Okay. In other words, we're trying to validate our own derivations. So let's go ahead and do this. I'll do this one with a separate text editor so we can look at the question and also look at the answer at the same time. So I'll just go ahead and copy post 6. Post 6 is x is 4, z is 5, and y is 4. All right. So if you look at this code here, what can we say about pre-6? Now there's no derivation required here, no steps to be shown when you get back to pre-3, but when you go forward again, you have to show the steps. But I'm just showing you all the steps here, individual steps. What can we say about pre-6, knowing that line 6 is y gets 4? Let's look at these items one by one. Do you think we can keep x equals 4?
Yes.
And that's because Nothing changes, exactly. How about z equals 5? You can keep that too. What about y equals 4? Can we keep that?
No.
No, because it's not reversible. Okay? Line 6 is changing y to from whatever it was to 4, but it doesn't leave us a way to reverse the operation. So we have to lose that piece of information when we get to pre-6. Post 5 is pre-6 because these two lines are consecutive. So what do you think we can say about pre-5? First of all, can we still maintain x equals 4? Did line 5 change x? No. So if x equals 4, if x equals to 4 after line 5, what can we say about x before line 5? It didn't do anything to change x, so it has to be the same. So this part we can keep. What about z? We changed z here.
Reverse function.
Can we reverse the operation?
Yeah.
Are we sure we can reverse z?
Yeah.
No, we would have lost the value of the previous z. Because this is not z gets z plus 1, it's z gets x plus 1. So we change the value of z without leaving us any way to reverse the operation. So we actually lose that information too. Are we okay with that? Okay. What about post 4? Well, post 4 is the same as pre 5. What about pre 4? Let's see what we know after line 4 executes. Right after line 4 executes, we know x equals 4. And what do you think line 4 does to x? It doubles the value of x. As a result of the doubling, x became 4. So what would be the value of x before the doubling? 2. X equals 2. All right, very good. X equals 2. And we're almost there. Post 3 is pre 4. Can we say anything about pre 3 over here? Well, first of all, can I say anything about x before line 3? We cannot. Because the value of y was used to completely overwrite the value of x. Can we say anything about y then? 2. Y equals 2. Very good. All right. So we are going to start with pre 3 equals y equals 6. Excuse me. Pre 3 is y equals 2. And then we'll go using forward derivation to see if we can end up with the post 6 that we have. Are we doing okay so far with the reverse operation?
Yeah.
Okay?
Oh, sorry. Do we need to show this work
No.
during the exam? Just
You
say
do
it.
not need to show the work, but you do need to indicate what you think pre 3 is.
Okay.
And then the forward operation is where most of the points are.
Okay. So we can ignore this. Just say pre 3 is y equal to 2. That's it.
Correct.
Okay.
All right. We ready? All right. So let's go ahead and look at post 3. How do we derive post 3 from pre 3? Remember all those questions that we have to ask? Yep. Okay. So the right-hand side of line 3 is f of x is y. Is that reversible?
No.
It is not reversible. Okay? So we can say f of x has no inverse. Which rule should we use then?
Yeah.
Use the forget rule. Okay. All right. So what we'll do is we'll say post 3 is the result of the forget rule applied to the precondition of line 3. What are we forgetting? Components containing x, which is the left-hand side of the assignment. And then after the forget operation, what can we assert? What do we know for sure? Equals y. Very good. What is pre 3? Pre 3 is y equals 2. Does y equal to mention anything about x? Nope. So we can keep it. So we have y equals 2 and x equals y. You have to take this one more step. You have to say y equals 2 and x equals 2. Because y equals 2, so we can actually push this one step further. Without pushing this one step further, it's not going to give you the same answer. Are we doing okay so far from pre-3 to post-3? Now we can work on line 4. Pre-4 is post-3 because those lines are next to each other. And how do we get to post-4? Well, we have to do the same thing. The right-hand side of line 4 is f of x equals x plus x. Is there an inverse function?
Yes.
F prime of x, which is the inverse function, is going to be what? X divided by 2. Not x minus x. Because I know someone's going to say, oh, we can reverse addition with subtraction. That would be disastrous because x minus x is always 0. So it's x divided by 2. And so we can use the substitution rule. So when we use the substitution rule, the post condition is the substitution rule applied to the precondition of the same line. We're replacing all occurrences of the variable on the left-hand side, which in this case is x, by f prime, which is the inverse function applied to x. What is pre-4? Pre-4 is this mess here. So we'll just copy and paste. I can copy and paste. And then f prime of x is x divided by 2. And then in the next step, I'm just going to do all the substitution. Y equals 2 is still the same because y is not x. There's no substitution here. And over here, it is x divided by 2 equals 2. And if you want to do one more simplification, then you get x equals 4. Are we doing okay so far with post 4? The post condition of line 4? Okay. Let's move on to line 5. Pre-5 is post 4 because those two lines are next to each other. And let's see how we can work with post 5. F of z in this case is x plus 1. Is there an inverse function? If the function does not refer to the variable inside the parentheses, it is not reversible. In this case, it is not reversible. So we have to use, no inverse function, use the forget rule. Hey, I'm actually giving you some hints of how to do your homework assignment, because you have to use the same rationale to explain which rule you're using. But in addition to the substitution rule, you also have to deal with the conditional state. Okay. So we have to use the forget rule, apply that to the precondition of the same line. And what are we forgetting? Components containing which variable? Z, because Z is the one on the left-hand side. And after this, what do we know for sure? Z equals x plus 1. Now, it is very important that we do not use the assignment operation here. Why? What is the difference? What is the difference between this and that?
One's used to different situation. I mean, like, one is used for the box and one is for this.
Okay, they're entirely different beasts.
The assignment operator implies that you're already forgetting the previous value and assigning a new value over that.
Okay. Well, let's go back and that's true. That's right too. Let's look at the AND operator here. It's a logical operator. What do we expect on both sides of a conjunction in terms of what kind of value can go onto both sides of the conjunction? Boolean, true, false values, right? Does this give us a true, false value? Z is x plus 1, Z is not x plus 1. Is that a true, false value? It's a true, false value, right? X equals x plus 1 can either be true or it can be false. What about the alternative? Because a lot of people make this kind of mistake. What kind of value does it give me? It does not give me a value. It is an operation. Okay? And that's why this version does not make any sense. It cannot be an assignment operator. It can only be a comparison, because that's the only way I can get a true-false value to make it work with the conjunction. Is that okay? All right. So now that we have spelled out the template, we can go ahead and forget. I have a little advantage here because I can copy and paste. Is there anything for me to forget?
No.
Because nothing mentions z, so I get to keep the entire thing here. And then just on top of that, we can say z equals x plus 1. And just like before, I'm going to push this one more step and say y equals 2, x equals 4, and z equals 5. Okay. Any questions about post 5? We are only one step away from finishing this. Let's go to line 6. Line 6 is actually an easy one. On line 6, what is the right-hand side? F of y is 4. Do you think it's reversible?
No.
There's no inverse function. Okay. So if there's no inverse function, we say no inverse function. Use the forget rule again. When we use the forget rule, the post condition of line 6, oh, forgot one step here. Pre-6 equals post 5. Post 6 is the forget operation applied to pre-6. What are we forgetting? Things containing which variable? Y. Okay. And after line 6, what do we know for sure? Y equals 4. And we're going to expand pre-6. So pre-6 is post 5, which is this mess here. This time, do we have something to forget? Y equals 2 has to be forgotten. So we can only retain this portion. And y equals 4. We're done. Is that our original post 6?
Yes.
So we are it's consistent. Very good. Let me make sure I save the file so we don't lose it. So that's the second question. Let's move on to the third one.
Question.
Yep.
For the pre-4, can you go back? Yeah, for pre-4. So we're getting the inverse for x plus x, right?
Mm-hmm. The right-hand side
How did it
is.
happen?
Sorry?
How did it happen? Like, why we can't put minus there? X minus x.
X minus x is 0. That's all.
X plus x is 2x.
Mm-hmm.
And to reverse twice x, you have to have basically x divided by 2. Huh?
Okay.
Divided by 2 is the inverse function. X minus x does not reverse the operation.
Okay.
Moving on to the third question. Okay, so this is just another trace. I think you guys can do this one. What do you think? It's just step by step, right? Traces are easier than pre and post conditions for most people. But it's also difficult in a way because if you make one mistake, then the rest will be wrong too. All right, so unfortunately this is a spreadsheet. I can still do it, it's just not as convenient. All right. How am I going to do this? I'll just copy and paste it into its own document and then save it. because of the sheer size of this class, I probably will shy away from open-ended questions like this, and instead, I'll change the format of the question to multiple choice, which is both easier and harder for you. It's easy in a way. Sorry, go ahead.
Put all the common mistakes as answers. Multiple choice.
With multiple choice, you can, with this kind of question, you cannot just kind of plug it in and see if it works. You still have to go through the trace on your own and then select the right answer.
It doesn't matter that there's no line 6 in your code fragment.
It's okay. We just don't trace line 6. Those lines do not have to be consecutive. Just like good old basic, right? You go by 10, whatever. All right, so let's go ahead and trace this code. What do we say on line 1? This is actually the precondition here. So line 1 is going to do something. We have a comparison. X is different from Y. Is it true or false?
True.
That's true. Where do we go next?
Line 2.
Line 2 is the beginning of a conditional statement. It has its own condition to evaluate. X is less than Y is false. True, because X is 2, Y is 4. Then we go to line 3. What does line 3 do? X gets X plus 1, so X becomes 3. And then where do we go?
Line 2.
We go to line 5 because the two conditional statements are consecutive. They're not. It's not like one is inside the other one. They're consecutive. So when you're done with one conditional statement, you have to move on to the next conditional statement. So we move on to line 5. X is greater than Y is false. And then where do we go? And we go to line 1. The ones have it. That's because line 5 is, the condition of line 5 is false. So that will get us out of the conditional statement, but there's nothing after the conditional statement. So the conditional statement is our last statement inside the loop, and that's why we have to go all the way back to line 1. All right? Is that okay?
Yeah.
All right. So on line 1, we reevaluate X is different from Y. Is it true or not? It's still true because one is 3, the other one is 4. We move on to line 2. X is less than Y is true. We go to line 3 again. X increments from 3 to 4. And then we get out of the conditional statement to line 5 again. Line 5 is asking, is X greater than Y?
False.
That's false. And then where do we go? 1. X is different from Y is false. And then post. Okay. It's very important that we don't jump from this to post right away. You have to go back to line 1, confirm the condition of the loop is false before you get out of the loop, and then go to post. Any questions about this one? No questions? I will make sure we save it to today's folder. I think that's the third question. And we can now move on to the last one. There are only 4 questions. When it's open-ended like this, we only have 4 questions. Which means if it's multiple choice, we will have more. Okay, this one is a slightly different type of question. It asks, if I want z to be 0, can you give me an example that of x and y to make it go to line 2, basically, so that z ends up with a value of 0. So let me just read the question here. If a case is impossible, state so and briefly explain why. Otherwise, state a specific value for x and y, or x has one value, y has one value, to make it happen. So I'll keep this one on the screen, and I'll use the text editor to indicate the answer. 4. All right, so looking at the code here, how can I make z equal 0? Give me an example of one value of x and one value for y. X has to be 0, and y equals 1 would work. You know, y equals negative 2,000 would work. You know, there are tons of examples you can give. How about the case where x equals 1? How can I make z? Excuse me. How can I make z equal 1? Okay, x has to be greater than 5. 6 would work. Okay, and y has to be greater than x. The closest one is 7, 30. You know, doesn't matter. 31. Okay, what about z equals 2? How can I make z equals 2 after this algorithm?
0. X is 0.
X has to be 0.
Y has to be 3.
Y has to be 3. Okay. Z equals 3. How can I make that happen?
X can be 6.
Okay. X is
It
6.
won't work. No, it won't work.
And what?
Won't work.
The branch.
The dead branch gets
It's
cut
a
off.
dead branch. Very good. Now, why is it a dead branch?
Because
Yep.
of line 3.
Because of line
Satisfies
3.
Line 3 before it gets there.
Line 3 goes.
Okay, so do we know for sure that everything that can make line, let me take it back. Are we sure line 7 is not possible? Z equals 3 is not possible. I think it is possible. There's a difference between these two lines. One is a conjunction, which is more restrictive. The other one is a disjunction, which is less restrictive. It doesn't need both to be true at the same time. Okay?
That's not and
Y is 2.
So wouldn't you say that?
How about that? Okay, now what you need to do is to look at this proposed condition here and make sure it will make everything before that false and only make this one true. Okay, so we'll run this through the program. So we are assuming x equals 6 and y equals 3. Would it make the first condition of line 1 true? Definitely false, right? Because x equals 6, this one requires x equals 0, so the first condition has to be false. The second one is the tricky one. Would the second condition, or the one on line 3, would that condition be true or false once we say x equals 6 and y equals 3?
False.
It will be false. So we are not going to execute line 4. We are not going to take that branch. What about the one on line 5?
False.
It's going to be false because x equals 6. That one requires x to be 0. So we actually have one case. We can list at least one case to make z equals 3 after the algorithm. What about z equals 4? Can we make that one happen? Yeah, we can make that happen. X equals 2 maybe? Right?
Yeah.
Well, let's double check. Well, we also have to say something about y. So this time you have to be careful because you have to pick a y that is not greater than x. Because if you pick y to be 3, then z equals 3 will pick up, line 7 will be true, and then line 8 will execute. So you just have to make sure that y is the same value. That will work too. Can we double check this?
Yeah.
The thing about this is you can always double check. You just say that assuming x equals 2 and y equals 2, go back to the first line. That's definitely false. This is also definitely false. This is definitely false. This one is false or false, which means the whole thing is false. And this one is true. So we can, in fact, make z equals to 4. The last one is z equals 5. What do you think?
X is negative.
Yep. X is -3 and y equals -3. You have to pick y carefully because otherwise you can potentially make line 7 true even though x is negative. Are we doing okay so far with this example? Okay. Yep.
So we have to make all the previous statements false in order to get to let's say line 5 to make z equals 4.
To make z equal 4, you mean?
Yeah. we need to make other statements that.
Yes. Because that's the nature of a multi-branch conditional statement. You evaluate the conditions from top to bottom. As soon as one is true, you execute that branch, and then you get out of the entire multi-branch conditional statement.
Okay.
Yep.
So the first branch doesn't need to technically be the first branch can be by itself, right? It doesn't need to consider the other branches because it's just the first one.
That is correct, because it doesn't have any conditions before that, right? Yep.
Can you explain line 7 and 8, please? How you get the z equal 3?
Oh, okay. We are talking about this condition. Why would it lead to the execution of line 8? That's your question.
Yes.
Okay. So we'll plug it in and say that x equals 6 and y equals 3. If x equals 6, this is an OR too. Okay, so would that, it makes it false too, right? X equals 6 makes x equals 0 false, and then y equals 3 will make y is less than 2 false, right? So this one is false. We have no choice but to go to line 3. We look at this condition here. X is greater than 5 is true, but y is greater than x is false. True and false is false. So this entire condition is false. We cannot take this branch. We have to move on to line 5. Line 5 checks, we need both of these to be true. X equals 0 is going to be false, so we don't even need to check y. Then we get to line 7. X is greater than 5 is true, and or y is greater than x, but I don't need the second condition to be true, because this is a disjunction. Having the first condition being true is enough for us to go to line 8.
Okay. And we have to avoid that the y greater than x is true, right?
Mm-hmm.
Otherwise, it will go to line 3.
Correct. We need to make one of these false so that line 3 doesn't catch that particular case. Any questions about the question number 4? Yep.
But isn't, if we make those statements true and keep going with true, then okay, if we have z equals 2, we move to the line 7.
No, you don't. As soon as you execute line 6, you get out of the conditional statement.
Oh, we're just posting it?
Remember, the multi-branch conditional statement looks like this. You have one branch here, you have one branch here, and you can potentially have as many branches as you want. But what happens after you're done with one branch? You go all the way out.
Okay.
Each branch will, after you're completed with each branch, you go all the way out of the conditional statement. So that's why after you execute line 6, let's say you get to line 6, after you execute line 6, z gets a value of 2, you get out of the entire conditional statement. You don't care what the other conditions are after that.
Okay.
Okay? Yep.
Then the z equals 5, the x being -3 and y being -3, that would be caught by the first line, wouldn't it?
That would be cut by the first line, yes.
So you can't get to.
You're right. There's no way to get to z gets 5 because this x has to be a negative value in order to get here. So the smallest, the largest negative value is -1, and y has to be less than or equal to x, and the largest one is -1, and that will make the first line true too. So this is actually a dead branch. Very good. Is a dead branch because when we use the remember, yes, go ahead.
Yeah, I also think that c equals 2 is also a dead branch because it makes it to get x equals 0. We make the first statement true, so there's no way to get to that one c equals 2.
Yes, thank you. I forgot to run all the values through. so to be sure, whatever value you pick, you have to run through the entire algorithm first to make sure that none of the earlier branches can potentially catch it. And line z equals 5 is a dead branch because that mostly has to do with line 9 combined with line 1, line 9, and also line 7. Those 3 are responsible for line 12 being a dead branch. Line 1, line 7. Are there any questions? You guys caught all of my mistakes. Very good. No questions? All right. Let's see if I have any more practice tests. Well, there are more practice tests here. You can see all of the practice tests are about the same. Yep, go ahead.
When's the exam? What day is the exam?
It's 1 week from today.
Oh.
Yep. So the actual exam is 1 week from today, so that will be next Tuesday. Which leaves you, Thursday. If you study the material and you have any questions, you can bring the questions on Thursday. We can still talk about it. Any other questions about the practice exam? You can also go through the other practice exams. They're similar, very similar in nature. But I think this time I'll switch from open-ended question to multiple choice. Yep. No, you just have to circle the answer on the piece of paper itself. So that way you don't have to buy anything, and after that I can grade it and return everything back to you. Any other questions?
Want to show us an example of how the multiple choice is going to look like?
It's going to be, I will give you the algorithm, and then it's either a short answer, like you have to tell me what is the value of y at the end of the algorithm, or it'll be multiple choice, like I'll give you a selection of potential values of potential values of y when the algorithm completes. So you still have to trace it. It's just that I don't have to correct the entire thing. I can just say, oh, okay, you picked C and that's the right answer, the wrong answer. Now, because it's a multiple choice, I can also ask you, how many times are we going to go over line 3? So you won't know until you actually trace it, right?
Yeah.
So makes my job easier, doesn't make yours any easier. But remember, I have about 50 of these things to grade, so it's a little bit different. The scale is different. Let's go back to arrays and see what else we can do with arrays. Do we still remember anything about arrays? Yeah. It's a box. Yep. All right. So we'll go ahead and start with section 5 here, how to search for a particular value in an array. All right. So we'll go ahead and use the text editor for that purpose. All right. Oh, by the way, I was approached by one of the professors who teaches cisp360. And after teaching P300 for many years, this is the first time I heard this feedback, that I'm not teaching enough algorithm design in this class because I'm just focusing on the mechanisms and how to trace a program. But I think I actually go through a lot of design issues as I derive algorithms. So I'll kind of put more focus onto the design part so that hopefully by the time you guys get into CISP 360, you'll be able to design algorithms to solve specific problems. All right, so we want to search for a particular value in an array. How can we do it? So I'll give you some examples, and I'll say, let's say A is an array, and I tell you ahead of time that the first element has a value of 56, the second element has a value of, say, 71, the third element has a value of 6. And I want you to tell me whether 12 is one of the values in the array elements. What do you think? No. But which algorithm did you use? What systematic method did you use to figure that out? It's called the eyeball algorithm, right? We just took a glance and go like, nope, 12 is not there. Did you search in a particular order? Did you go read top to bottom? Did you read bottom to top? Or did you just scan all three numbers at once and say, nope, none of these is 12? Probably the third case, right? Because the human vision can do it. We can actually interpret multiple numbers when they're right next to each other. We can actually match numbers like that without any problems. So this is not a very good example, is it? So next, we'll go look at, let's say use a phone book. Okay, so we're going to use a phone book as an example. And someone is going to say, but Tag, that's not a very good example, because when we look up a name in a phone book, it's alphabetically sorted, and it's not a very good example of how to search for a value in an array in general, because a sorted array is much easier. How about I change the question and not look for a particular name? I'm looking for a particular phone number. So I give you a phone book, just like a regular phone book, which is ordered by the name or business. And I'm looking for a particular phone number instead of the name of the business or the person. How are you going to do it now? I'll try my luck, right? I'll flip to a certain page and go, yep, it's not here. Okay, is it here? No. Okay. Is that how you're going to do it?
Categorize the numbers and then start with a certain number.
You have to start from page 1, the first entry, and then linearly go through every single entry, right? When do you stop? That's the most important question, is when do you stop?
Find the number.
Until you pass out, right? It's like because the phone book may be a Los Angeles phone book, right? Not Sacramento, not Davis for sure. It's Los Angeles. Okay, so when do you get out of the loop? When do you stop? There are two ways you can get out.
You reach the end and find the number.
Okay, you cannot find the number. You get to the end, you confirm that none of the entries in the phone book matches the number that you're looking for, or
You find it.
you just find it. You just found it. Okay, so either way, you have to get out. Okay. So what we'll do is we'll write the algorithm here, and this is the part about designing an algorithm. Okay, this is important because this is really hard to teach. The mechanisms is easy to teach. Even the pre and post conditions are relatively easy to teach because they are just math. Okay, the design part is difficult to teach. Why? Well, it's creativity, but it's also experience. Okay, for the most part, you have to understand the tools well enough. Then you can come up with the algorithm. But I want to make this systematic as much as I can. I will make the design part also systematic. Because what we'll do, we'll go by this. We'll use the same method as we always do. Do you think this involves a loop? Are we doing something repetitively?
Yes.
Okay, so that's good. So we say there's a loop of some kind, and here's the end of the loop. We exit when what? Remember the two conditions that can get us out of the loop? We'll just spell it out. What are the two conditions?
Locate the number or run out numbers.
Okay, so I'll just say when the item is confirmed not in the array. Make this a little bigger. Or, what do you think the other reason is? Confirmed in the array, right? All right. I'll call this revision 1. Because it is significant. In other words, when you design an algorithm, it's best to look at it first and say, are we doing something that's a one-shot thing, or are we doing something that is repetitive? Okay, we're doing something over and over again. Now, when you are, most of the time it is repetitive, okay, because there are very few algorithms that are one-shot. So most of the time you're doing something repetitive. If you are doing something repetitive, can you just specify vaguely how you're going to stop? It doesn't have to be very specific. You don't have to use programming notation. It's just in terms of concept, when do we get out of the loop? And don't worry about what goes in the loop first, because once you know the condition to get out of the loop, it will give you some hints of what you need to do in the loop. Are we doing okay so far with just the basic concepts of what do we do when we have to design an algorithm? Now, when we talk about in the array, the item, and stuff like that, it's kind of vague. So the next thing we want to do, I'll just call these different revisions. So this is version 1, which is really vague, doesn't really say a whole lot. Version 2 is going to clarify things a little bit. So we'll use some terms in programming. We'll say the array is array A. The item we are looking for is K. Usually we use K for key. Okay. So can we rephrase something? Oh, okay. Now, when you use an array, would this make any sense? Can this be either true or false? What does it mean? What is A? A is an array, right? So using our analogy from the previous class, what is an array? It's a box, right? It's a box of, say, coffee mugs, and each coffee mug can have a different level of liquid. What is K here? K is not an array. It's a regular variable. And in the analogy, what is a regular variable? It's a coffee mug. So I'm asking you a question of, is the liquid level of this box the same as the liquid level of this coffee mug? Does that make any sense to you? No, because we're comparing different objects here, and they're not compatible. So A compared to K doesn't make any sense. How do you make this make sense? Would that make any sense? In other words, can we at least say whether this is true or not?
Yes.
Pick the first cup out of the box and compare the liquid level between that coffee mug and the coffee mug called K. Does that make sense? We're comparing the liquid levels between two coffee mugs, and that makes sense. Okay, well, why do we have to say something like this? Because when we re-express the loop here, confirming something that is not in the array is a little harder. How do we confirm something is actually in the array? Some element in A has the same value as K. But I cannot leave the square brackets empty. I have to stick something in the inside. Okay, for the lack of a term, we'll just stick I there. Why not a constant? Why can't I just put a 0 here? Because it's only going to be comparing A bracket 0 all the time. Okay, so if we stick an I here, that means, hey, we have some other way to change I later on. So we'll say, the index into the array is I, variable I. Okay. Are we doing okay so far? So that's version 2. Version 2 is a big improvement over version 1. Version 3. It looks like we have a variable I as to serve as an index, so that we can change the value of I, and we can compare the value of K to different items inside a box, inside array A. How are we going to move I around or change the value of I so we can look at different things inside a box? Well, there are several ways. There's no right answer or wrong answer here. It's just what is easiest to express. Do you want to go by random? We don't want to go by random because if you go by random, you never know when you can get out of the loop. Because you can keep looking at similar values all the same time. Can we look all the way? In other words, if this is a phone book, can we flip to the last page and look up the items, all the way back to the first page? That's okay. That works. And we can also start from the first page and look all the way to the last page. How would you want to do this?
First last. First to last.
First to last. Okay. Now, if we're going to go from first to last, how should I initialize I? Because we have to start with something, right? Let's start with 0. Okay. I gets 0, and this has to go before the loop because we don't want to keep initializing the value of I. Okay, that's good. And if I can neither confirm that the value that I'm looking at is k, nor we have looked through the entire array and confirmed that the item is not there, how am I going to move on and look at the next item?
I get the I plus 1.
I get I plus 1. We are incrementing the index so we can look into the next one. Okay, good. And we'll just call this version 3 because we are not quite sure how can we confirm the item is not in the array. Just because a bracket I does not equal to k is not a good reason to get out of the loop. Is that true? Because there are other items that we may not have seen yet in the array. Is that making any sense? Okay. So the version 4 is the difficult one. How do we get this condition done? How can we confirm that the item is not in the array? All right.
If I is bigger than array length.
Uh-huh. So we suspect that this has to do with I has to somehow relate to bar A bar. But how should they relate to confirm that we have examined every single element in the array and we have confirmed that neither or none of them matches k.
Less than
It's a little bit easier than that. Okay, well let's take a look. Let's think this through. There are only 3 possible things and combinations of those, right? I can be less than bar A bar, I can equal to bar A bar, I can be greater than bar A bar. What do you think it implies when I is less than bar A bar? That we haven't seen everything yet. Okay. What if I equals bar A bar? Now this is okay, I can combine these two. What if I is greater than or equal to bar A bar? Well, first of all, if I is greater than or equal to bar A bar, can I check A bracket I? What is the index of the last element in an array relative to bar A bar? Is bar A bar minus 1. That's the number of the last item in an array because we count from 0. Is that right? Okay. So that means if I is greater than or equal to bar A bar, it doesn't even make sense for me to try to access A bracket I. Besides, what does it mean when I is greater than or equal to bar A bar? We have just gone through the entire array because otherwise we would not be there. So that means this is our ticket because this when I is greater than or equal to bar A bar, it means we have gone through the entire array and none of the item inside the array matches k. So we have confirmation in this case that k is not in the array. Are we doing okay? All right. That's version 4. we have one more revision to go because we haven't decided what kind of loop we want to use. What do you think? Should we use a pre-checking loop or post-checking loop? Should we check the condition first or check the condition later?
Pre-check.
Pre-check?
Yes.
Okay. Pre-checking is the correct answer. So when you use a pre-checking loop, the loop is going to look like this. What should we put in here? When you look at this condition here, it's called an exit condition because this condition tells us when to stop repeating. This condition needs to tell us when to stay in the loop. So what do you think we have to say here? Okay, let's pick the easy answer first. The easy answer is whatever the other one is not. Right? So we just need something that is negating the exit condition, and that becomes our stay in loop condition. Is that making any sense? But it's hard to read. But we'll go ahead and fix it in version 6. So in version 6, we're going to change this a little bit. Have we talked about something that will allow us to kind of fix this problem? It's called De Morgan's law. Okay? So De Morgan's law allows us to put the negation into the inside stuff, but we have to change the or to an and. So in this case, we can change this to an and, but then we have to do the negation in the inside. Okay, that's De Morgan's law. When you compare this condition here to this condition here, it is called De Morgan's law. But does it make sense? How many people still kind of remember De Morgan's law from last time? Okay, I'll just go over that again. De Morgan's law states something like this. It is not the case that A or B is really saying the same thing as not A and not B. Can we prove it? Well, A is Boolean and B is Boolean, right? So A can be true or false. When A is true, B can be true or false. When A is false, B can be true or false too. What should I put here? A is true, B is true, A or B is true, not true is false. What about this one? A is true, B is false, true or false is true, not true is false. And this one is kind of symmetric, it's false. This one is going to be what? True. So now we move on to the other column. Not A is false, not B is false, false and false is false. Not A is false, not B is true, false and true is false. Not A is true, not B is false, true and false is false. Conjunction. And here we have not A is true, not B is true, true and true is false. True and true is true. Okay. So that means, this expression here is the same as this expression for all possible values of A and B. And that's why we can say that whenever you see something like this, you can transform that into something like this, and vice versa. They are equivalent. And that's how we transform from this condition here to this condition here. But we're still seeing a lot of negation. Right? Can we simplify this a little bit more to get to version 7? what is an easier way to say that I is less than or equal to bar A bar is not true?
I is less than.
Yep. And what is the other way to say that A bracket I equals K is not true?
Bracket I is not equal to K.
Yep. Okay, so we just say this is different from. That's the solution. Are we doing okay so far? But we still have one problem.
What's K?
Hmm?
It's K. That's your problem. I mean,
Yeah, K has to be given. You know, what you're looking for and the initial value of the elements, they have to be given. But there's one problem here. The problem is when I equals to bar A bar, what are we going to do? In other words, what if K is not in the array? Now let's think about what happens when K is not in the array. If K is not in the array, that means this condition is going to be true or false for all elements. It's going to be true for all elements. What happens in the last iteration? In the last iteration, before this statement, I would be bar A bar minus 1. And then it will go through the assignment statement. I becomes exactly bar A bar. We go back to evaluate the condition again. I equals bar A bar, I is less than bar A bar is false. Right? But this is a conjunction. If we are going to evaluate the right-hand side, then we'll be we're trying to access an element out of bound. Because I is bar A bracket bar A bar is not a valid element. So we have a problem. Does everybody understand what the problem is? It's because with a conjunction, it depends on the implementation. Because with a conjunction, if you evaluate both sides of the conjunction, then you'll be evaluating this side when I equals to bar A bar, and A bracket bar A bar close bracket is an element that is out of bound. It is not an element in the array, by definition. So what are we going to do to fix this problem? we take the easy route out. We change the meaning of and. Okay? So what we do, this works because of the following. I will show you where we are in the notes too. This works because of short-circuited Boolean evaluation, aka lazy. Now, what do we mean by lazy? Well, lazy means when you evaluate a conjunction, if the left-hand side of a conjunction is false, can you conclude the actual value of the entire conjunction? False and whatever is false. Okay? So that's what I mean, because almost all programming languages now will do this. They will implement short-circuited Boolean evaluation, which means when you have a conjunction and the left-hand side of the conjunction evaluates to false, it does not even bother with the right-hand side. Okay? And that's the only reason why this code is going to work. Because most people think lazy is bad, right? Not lazy is good. Doing everything the way it's specified is good. Not in this case. In this case, laziness is good because we avoid the problem of accessing an element out of bound because of lazy evaluation. In the past, only certain languages have short-circuited evaluation. Now, almost every programming language has short-circuited evaluation. So you can kind of make this assumption. The only exception is true Pascal. But nobody implements true Pascal anymore, so we don't have to worry about it. Even Turbo Pascal has short-circuited evaluation. Okay. So we'll stop here, and if you have any questions about the material for exam 1, bring it on Thursday so we can talk about it. And don't leave just yet. I just want to show you where we are in the notes. We're in topic 8 already about short-circuited Boolean operators. All right.